Welcome to Chapter 10. We're going to be talking about consciousness. Slide 2. In talking about consciousness, we're going to cover three broad topics. First, we're going to get an idea of the difference between conscious and unconscious processes, and then we'll take a look at sleep and dreams, and after that, we'll wrap it up with hypnosis and other states of consciousness. Slide 3. As mentioned in previous lectures, psychology began in the late 1800s as the scientific study of the conscious mind. However, researchers soon abandoned the effort, and the behaviorists argued convincingly that consciousness is an internal, private experience that researchers cannot observe or measure. At the time, they were correct. They didn't have a method to measure brain activity or anything else that might correlate with a private experience. Therefore, psychologists redefined their field as the study of behavior, right? This is the pendulum swinging from mind to behavior. And while the behaviorists were right at their time that research on consciousness was impossible, the times have fortunately changed. And four advances that have facilitated meaningful research in consciousness are: first, we have an operational definition of consciousness. Second, we ask limited and answerable questions. Third, we have modern methods to measure brain activity. And fourth, we have ways of controlling consciousness of a stimulus. So this refers to the methods that we use. Going over each of these, a dictionary might define consciousness as the subjective experience of perceiving oneself and one's surroundings. However, that definition relies on the phrase subjective experience, which is no better defined than consciousness itself. Researchers use this operational definition. If a cooperative person reports being conscious or aware of one stimulus and not of another, then he or she was conscious of that first and not the second. As to the limited research questions, for the time being, we postpone the questions that are the hardest to answer and focus on limited answerable questions like, how does the brain activity when someone is conscious of a stimulus differ from activity when someone is not conscious of the same or a similar stimulus? Moving on to methods, researchers today have several methods to record brain activity without invading the brain, such as EEG, MEG, fMRI, and a bunch of other alphabet soup-sounding acronyms. And then finally, by using the methods of masking, flash suppression, and binocular rivalry, those are tough words to spit out. By using those methods to present a stimulus, we can prevent conscious perception of it. Let's talk about that just a little bit more. Take two of these examples. Slide 4. So here's an example of what a masking task would look like. So if you were to take the top row, you would be presented with a blank screen. And then the word in the middle, Grove, would flash for a short period of time, like 500 milliseconds. And then it would go back to the blank screen. And your task is to say what the word was that was flashed. Now, people are much better at this task than they are at the one below it, where there is a masking visual field, and then the word is presented. And then it goes back to that masking field. That interference of the design of the pre and post environment around the word seems to confuse the conscious mind, and it makes it more difficult to get the word that was presented from the participants. So the take-home point is, when we mask the stimulus, we are able to hide it from consciousness purposely, and that's advantageous to us when we want to research consciousness. Slide 5. Binocular rivalry. Man, that is such a weird word to say. Binocular rivalry. This demonstration shows that if you were to take like two pieces of paper and curl them up into cylinders so that you have like fake binoculars, all you need to do is look through those tubes or cylinders and alter the focus of your eyes until the two circles merge. And then you can alternate between seeing red lines and seeing green lines. Again, by doing this, you can change someone's attentional focus. By changing their attentional focus, you're essentially doing research into consciousness, considering that consciousness is mostly happening in working memory. Slide 6. When you become conscious of a stimulus, it produces more brain activity and more spread of the activity across brain areas. It also produces more inhibition of other competing brain activity. The images on this slide represent the different brain activity that occurs when words are visible and conscious versus words that are masked, like the technique we talked about a couple slides ago. So it might be difficult to see on this particular slide, but the visible words are activating more parts of the brain, and that's supposed to be represented in green, so you might have to look at it pretty closely to get this. But point being, when something is conscious, like a visible word, it takes up much more of the brain, as compared to when something is masked, it takes up less parts of the brain. So this demonstrates that consciousness is the ability of signals in your brain to not only activate, but to spread across the brain more so than when something is not conscious. So here's one of the ways that we can look at brain activity to determine whether or not somebody's paying attention to something, or is aware of it, or is conscious of it. Slide 7. It's interesting to note that your brain notices that something is meaningful or important even before you become conscious of it. Unconscious processes can do a good bit more than we once imagined they could. Slide 8. And some people might ask whether or not consciousness slowly phases in or it is an on-off procedure. Research seems to show that consciousness of a stimulus appears to be an all or none phenomenon. A stimulus either reaches a threshold necessary for spread or it doesn't. Slide 9. Another interesting note, consciousness does not occur at exactly the same time as the events. We are living in the past. We construct a conscious perception of events that have already happened. So, in order to do that, we are a couple milliseconds behind things that are actually happening in real time because we need that processing time to perceive what's happening in the environment. So we're perpetually living in the past is a way to think of it. Slide 10. Physicians distinguish various gradations of brain activity that relate to arousal, responsiveness, and presumed consciousness. In brain death, the brain shows no activity and no response to any stimulus. Most people consider it ethical to remove life support for someone who remains steadily in this condition. In a coma caused by traumatic brain damage, the brain shows a steady but low level of activity and no response to any stimulus, including potentially painful stimuli. In nearly all cases, someone in a coma either dies or begins to recover within a few weeks. Someone starting to emerge from a coma enters a vegetative state, marked by limited responsiveness, such as increased heart rate in response to pain. Someone starting to emerge from a coma enters a vegetative state marked by limited responsiveness, such as increased heart rate in response to pain. Responsiveness varies between a sleeping state and a wakeful state, but even in the waking state, brain activity is well below normal, and the person shows no purposeful behaviors. The next step up is a minimally conscious state in which people have brief periods of purposeful actions and speech comprehension. A vegetative or minimally conscious state can last for months or even years. Because people in a vegetative state do nothing, it's easy to assume that they're unconscious. However, results from brain scans suggest that at least a few patients in a vegetative state are actually conscious. Slide 11. And here's a demonstration of brain images of a patient versus a control, and the patient in this instance is in a vegetative state. And we can see when we ask them to imagine things, like tennis or some kind of spatial navigation, their brain replicates the activity of somebody who is not in a vegetative state. So in this instance, even though the patient is vegetative, their brain is reacting in the same way as somebody who is not in a vegetative state. Slide 12. Also, we have reason to doubt that people can accurately state the time that a conscious decision begins. Spontaneous movements and the decisions behind them gradually develop. They're not sudden. So for example, imagine yourself driving along when suddenly a deer darts into the road. You swerve immediately to avoid it. By contrast, if you decide you need to go into the left lane to make a turn, you move slowly. The gradual, spontaneous movements depend on a set of brain areas called the basal ganglia, which contribute much less when you act in response to a stimulus. The graphic on this slide shows a clock that is actually a timer. And as the dot moves around this clock/timer, patients are supposed to press a button when they recognize a conscious decision to move. Now, when we move on to the next slide, slide 13, we see that when their brains are being scanned during this process, there seems to be activity in their brain before they are conscious of the decision to move. And then, of course, the movement happens even further after that. This is a way of demonstrating that, in fact, we are not conscious of the decision-making processes that go on in our brain. We are just along for the ride. And then the chart next to the graph, the circle, is a demonstration of how consciousness is an all or nothing process. It is gradual and gradual up until it hits a threshold, and then once it passes that threshold, we are conscious and aware of it. Slide 14. Studies have shown that the brain activity responsible for a movement starts before a conscious decision. All of this to say, we have reasons to doubt that people can accurately state the time that a conscious decision begins. Spontaneous movements and the decisions behind them develop gradually, not suddenly. Some theorists have argued that consciousness is an epiphenomenon, an accidental byproduct with no purpose. But if consciousness does serve a purpose, what might that purpose be? One hypothesis is that conscious thought is a way of rehearsing possibilities for future actions. After you do something, you might ponder, that didn't go well. What could I have done differently? Then what would have happened? Ah, I see. The next time I'm in a situation like this, here's what I'll do. In that way, your conscious thinking modifies your behavior on some future occasion. Slide 15. Okay, hopefully we have an understanding of the difference between conscious and unconscious processes. And by going over it, it makes it even more confusing because the take-home point is we're not really conscious of much. But anyway, moving on to dreams and sleep. Slide 16. Humans have mechanisms that prepare us for activity during the day and sleep at night. Like other animals, we generate what's called a circadian rhythm, a rhythm of activity and inactivity lasting about a day. The rising and setting of the sun provides cues to reset our rhythm, but we generate the rhythm ourselves. Slide 17. Your circadian rhythm controls more than just sleeping and waking. Over the course of the day, you vary in your hunger, thirst, urine production, blood pressure, alertness, body temperature, and mood. Certain people have genes that alter their circadian rhythms. Those with genes causing a 23-hour cycle instead of a 24-hour cycle get sleepy early in the evening and wake early. The graphs on this slide demonstrate the circadian rhythms as they affect general performance on tasks. That's the bottom one, so that would be cognitive ability. And then the top one is body temperature. So the participants in this study are being kept awake for 72 hours, yet their body is still going through the circadian rhythms necessary to alter body temperature, as though they were going through the circadian rhythms of sleep and wake. I also want to point out how bad your cognitive performance is when you don't get enough sleep. So please, make sure you get enough sleep, people. Slide 18. All right, morning people and evening people. The older I get, the more of a morning person I become. And what does that mean? So morning people awaken easily, become alert quickly, and do their best work early. Evening people, on the other hand, take longer to warm up in the morning and do their best work in the afternoon or evening. Morning people have advantages in several ways, especially if school or work starts early in the morning. On average, morning-type students maintain attention better in the morning, do better on tests in the morning, and get better grades even when compared to evening-type students with the same cognitive ability and motivation. Most young adults are either evening people or intermediate, whereas most people over age 65 are morning people. If you ask people at what time they like to go to bed when they have no obligations, their mean answers shift later and later during the teenage years. Eventually, it reaches 1 or 2 a.m. by the time they're 20, and then it starts reversing slowly and steadily over decades. The fact that the trend continues gradually over a lifetime suggests a biological basis. Slide 19. If you travel across time zones, your internal rhythm is temporarily out of phase with your new environment. This experience is jet lag. It's a period of discomfort and inefficiency while your internal clock is out of phase with your new surroundings. Most people find it easier to adjust when flying west, where they go to bed later, then flying east where they would have to go to bed earlier. If you fly west, your circadian rhythm shifts a bit later each day until it catches up. If you fly east, your rhythm shifts a bit earlier each day. Slide 20. Some businesses run 3 work shifts, such as a midnight to 8, 8 to 4, and 4 to midnight. Because few people want to work regularly on the midnight to 8 a.m. shift, many companies rotate their workers among the 3 shifts. Employers can ease the burden on their workers in 2 ways. First, when they transfer workers from one shift to another, they could transfer them to a later shift. That is, someone working from 8 a.m. to 4 p.m. shifts to the 4 p.m. to midnight time, like traveling west, instead of midnight to 8 a.m., like traveling east. Second, employers can help workers on the night shift by providing bright lights that resemble sunlight. All of these examples about how to better the workflow is what's called organizational psychology. If this is something that you're interested in, you could certainly pursue it and make psychology a career for yourself. Slide 21. The circadian rhythm of sleep and wakefulness is generated within the brain by a tiny structure known as the suprachiasmatic nucleus. Oh man, that's a mouthful. Although the suprachiasmatic nucleus generates a circadian rhythm, light resets the internal clock, causing you to wake up more or less in synchrony with the sunlight. The suprachiasmatic nucleus, man, how many times are they going to make me say this, exerts its control partly by regulating the pineal gland's secretions of the hormone melatonin, which I'm sure most of us have heard of here. I take melatonin at night just to make sure that I'm ready for sleeping as soon as my head hits the pillow. And melatonin is important for both circadian rhythms and many species' annual rhythms of reproduction, hibernation, and so forth. Slide 22. Ordinarily, the human pineal gland, or pineal gland, starts releasing melatonin 2 or 3 hours before bedtime. Slide 23. Scientists have identified several benefits of sleep. The simplest is that sleep saves energy. Sleep also strengthens learning and memory to varying degrees, depending on the type of learning. When you learn something, your memory improves if you go to sleep within the next 3 hours, and it deteriorates after a sleepless night. A good night's sleep also improves learning the next day. People suffer when they don't get enough sleep. Sleep-deprived people become more vulnerable to illness, especially depression and other mental illnesses. They suffer lapses of attention and lapses of ethical behavior as well. So, again, let's all get our sleep in. I'm getting tired already, just talking about sleep. Slide 24. In the mid-1950s, French and American researchers independently discovered a stage of sleep called paradoxical sleep, or rapid eye movement, REM, not the band. REM sleep is characterized by rapid eye movements, obviously, a high level of brain activity and relaxed muscles, and that's why it's called paradoxical, right? Brain activity is high, but the muscles are relaxed. REM sleep is paradoxical because it is light in some ways and deep in others. It's light because the brain is active and the body's heart rate, breathing rate, and temperature fluctuate substantially. It's deep because the large muscles of the body that control posture and locomotion are deeply relaxed. Adults who awaken during REM sleep report dreams about 85 to 90% of the time, whereas those awakened during non-REM sleep report dreams on about 50 to 60% of occasions. Slide 25. Sleep researchers distinguish among sleep stages by recording brain waves with electrodes attached to the scalp. An electroencephalogram, or EEG, measures and amplifies tiny electrical charges on the scalp that reflect patterns of brain activity. Sleep researchers combine an EEG measure with a simultaneous measure of eye movement to produce a polysomnograph. Man, this chapter has me saying the craziest words. A sleeper first enters stage 1, when the eyes are nearly motionless and the EEG shows many short, choppy waves that indicate a fair amount of brain activity. As sleep continues, a person progresses into stages 2, 3, and 4. These stages differ in the number of long, slow waves. Stage 2 has the fewest and stage 4 has the most. These waves indicate synchrony among neurons related to decreased brain activity. Stage 2 is marked by sleep spindles, waves of activity at about 12 to 14 per second that result from an exchange of information between the cerebral cortex and the underlying thalamus. Sleep spindles are important for storing memory, and the improvement of memory that often occurs after sleep depends on the amount of sleep spindles. Sleep spindles are the key. A sleeper progresses through stages 2, 3, and 4, then gradually back to stages 3 and 2, then to REM sleep. The EEG in REM sleep resembles that of stage 1, but the eyes move steadily. At the end of REM sleep, the sleeper cycles again through stages 2, 3, 4, and then back to 3, 2, and REM. In a healthy young adult, each cycle lasts 90 to 100 minutes on average. Slide 26. Insomnia means lack of sleep. More specifically, insomnia is not enough sleep for the person to feel rested the next day. Insomnia results from causes including noise, worries, indigestion, uncomfortable temperatures, use of alcohol or caffeine, and medical or psychological disorders. Persistent insomnia should be treated by a physician. However, doing the following can help occasional or minor insomnia. You could keep a regular time schedule for going to bed and waking up each day. You could spend some time in the sunlight to set your circadian rhythm. Minimize exposure to television and computers in the hours before bedtime. I like to read a book right before I go to bed. Avoid caffeine, nicotine, and other stimulants, especially in the evening. Don't rely on alcohol or tranquilizers to fall asleep. After repeated use, you may be unable to sleep without them. Keep your bedroom cool and quiet. And exercise daily, but not shortly before bedtime. Try to do it earlier in the day. So if you do suffer from occasional insomnia, those things could help. Slide 27. Apnea means no breathing. People with sleep apnea fail to breathe for a minute or more and then wake up gasping for breath. Sleep apnea is most common in overweight middle-aged men whose breathing passages become narrower than usual. While awake, they compensate by breathing frequently and vigorously, but they cannot keep up this pattern while they're asleep. Treatment includes recommendations to lose weight and to avoid alcohol and tranquilizers before bed. Surgeons can remove tissue to widen the airways. Some people with sleep apnea use a device that pumps air into a mask, covering the nose and mouth during sleep, forcing the person to breathe. These are called CPAP machines. People with narcolepsy experience sudden attacks of sleepiness during the day. They also experience sudden attacks of muscle weakness or paralysis and occasional dreamlike experiences while awake. For people with narcolepsy, a combination of stimulant and antidepressant drugs helps maintain their wakefulness state during the day and blocks the attacks of muscle weakness. Slide 28. Some other sleep experiences. Sleep talking. Oh, this is a fun one. Sleep talking is a common experience that ranges from a grunted word to a clear paragraph. Many people talk in their sleep more often than they realize because they don't remember sleep talking and usually no one is around to hear them. Sleep talking is most common during stage 2 sleep, but it occurs in all stages. Sleep walking tends to run in families, mostly in children and mainly during stage 4 sleep. Some adults sleepwalk also, mostly during the first half of the night's sleep and not while dreaming. During sleepwalk, you have clumsy, apparently purposeless movements with only limited responsiveness to their surroundings. Sleepwalking occurs when the motor cortex and few other areas are active, while most of the brain remains asleep. Lucid dreaming is another example in which part of the brain is awake and another part is asleep. Lucid dreaming occurs during periods of increased activity at 40 hertz, 40 cycles per second, in the frontal and temporal cortex, with less arousal in the rest of the brain, right? And of course, lucid dreaming is knowing that you are dreaming while you are dreaming. Some people have prolonged creepy crawly sensations in their legs. And this is accompanied by repetitive leg movements strong enough to awaken the person, especially during the first half of the night. This condition is known as periodic limb movement disorder. And lastly, a night terror. A night terror causes someone to awaken screaming and sweating with a racing heart, sometimes flailing with the arms and pounding the walls. Night terrors occur during stage 3 or 4 sleep, not REM, and the dream content, if any, is usually simple, such as a simple image. Slide 29. Common usage implies that dreams are happy, right? When something is dreamy, you consider that it's good. Right? And another example is like Disney movies. Cinderella sings, "A dream is a wish your heart makes." Martin Luther King had a famous "I have a dream" speech describing a wonderful future. However, much or most of dream content is unpleasant, such as falling, being chased, or being unable to do something, at least as reported by participants in research. Although some dreams are bizarre, most are similar to what we think about in everyday life. For example, preteens seldom dream about the opposite sex, but teenagers do. However, we do not dream about everything we do in daily life. People seldom dream about reading, writing, using a computer, or watching television. People who become blind because of damage to the visual cortex lose visual dreaming as well as visual imagery. People who experience eye damage after about age 5 to 7 continue to have visual dreams, although their frequency of visual dreams declines over time. People who are born blind or who become blind in early childhood have no visual imagery in their dreams. Instead, they dream of sounds, touch, smells, and tastes. Slide 30. And we're back to Freud. Man, he just rears his ugly head everywhere. Well, he doesn't really have an ugly head, but... So, Freud, founder of psychoanalysis, he maintained that dreams reveal the dreamer's unconscious, because that's his most important thing, right? It's the unconscious thoughts and motivations. To understand a dream, according to Freud, one must probe for hidden meanings. Each dream has a manifest content, the content that appears on the surface, and a latent content, and that's the hidden idea that the dream experience represents symbolically. All right, so just my official stance on this. Freud's theory of dreams is super fun and not really meaningful in any way. Moving on. Slide 31. Modern theorists describe dreaming as a kind of thinking that occurs under conditions of low sensory input and no voluntary control of thinking. The two theories that at least the textbook refers to are the activation synthesis theory and a neurocognitive theory. Slide 32. Okay, and let's wrap this up with some hypnosis. You are getting sleepy. Slide 33. Hypnosis is a condition of increased concentration and suggestibility that occurs in the context of a special hypnotist-subject relationship. Slide 34. To induce hypnosis, a hypnotist asks a person to concentrate and then makes repetitive suggestions. The first steps towards being hypnotized are the willingness to be hypnotized and the belief that one is becoming hypnotized. Slide 35. While hypnosis has been used to alleviate pain and through post-hypnotic suggestion, it sometimes helps people combat bad habits like smoking. Many of the spectacular claims about the power of hypnosis become less impressive on closer scrutiny. Many people have attempted to use hypnosis to enhance memory. As recently as the 1990s, almost 1/4 of psychotherapists believe that all memories stated under hypnosis must be true, and almost half believe that hypnosis could recover memories going back to the time of birth. Today, only about 10% hold either of those beliefs. Under hypnosis, people do report additional details, mostly with great confidence. However, most of the additional detail turns out to be factually incorrect. Hypnotized people have an illusion of memory, but all the evidence says that hypnosis fails to improve the accuracy of memory and probably harms it. Slide 36. At one extreme, some psychologists regard hypnosis as a special state of consciousness characterized by increased suggestibility. At the other extreme, some psychologists emphasize the similarities between hypnosis and normal wakeful consciousness. Most psychologists regard hypnosis as a special state in some way, but not others. Apparently, people pretending to be hypnotized can mimic almost any effect of hypnosis that they know about. However, hypnosis is ordinarily not just role-playing. The effects that role-players learn to imitate happen spontaneously for the hypnotized people. Slide 37. And we'll wrap it up with some other states of consciousness. So for those of you that meditate, meditation is a systematic procedure for inducing a calm, relaxed state through the use of special techniques. Many studies document that meditation increases relaxation, decreases pain, decreases anxiety, and improves health in several ways. It's particularly useful for increasing people's ability to control their attention and resist distraction. Déjà vu is when people sometimes feel that the current experience is uncannily familiar somehow. Because it takes several forms, a single explanation may not suffice. Occasionally, someone is somewhere for the first time and sees it as familiar, as if he or she had been there before. Perhaps the person really had seen something similar, possibly in a movie or a photo. More commonly, people report déjà vu in a familiar setting. You might be sitting in your room or having an everyday conversation when you suddenly feel, this has happened before. In a sense, of course, it has happened before. But your sense is not that it's just similar to a past experience. Instead, it seems this particular event happened before, the same exact one. One man with epilepsy originating in his temporal cortex had a special feeling, an aura, before each of his seizures that included a strong sense of déjà vu. Brain scans suggested that his déjà vu experiences correlated with abnormal activity in parts of the temporal lobe that are important for memory. So there's an example of an attempt to study déjà vu based on brain imaging. Slide 38. And we're done. Consciousness. This is the good stuff. See you next chapter.